Students, the last class we have studied that that is the delta n. One examples I had given that one. That is the delta n is equal to 0 means Kp is equal to Kc you are taking. Next one, delta n is greater than 0 means Kp is greater than Kc you are getting. When the delta n is equal to 0, then less than 0, then what happens? Kp is less than Kc is there. That is the examples I had given in the last class. One example I had given. The another example I will give. The next one you have to take. That is the PCl5 is there. PCl5, phosphorus pentachloride. So it undergoes what happens here? Here also what happens? The equilibrium is attained here. Then what happens here? It forms what? PCl3 plus Cl2. PCl3 plus Cl2. So here what happens? When you see this reaction, you have to find out what? That is the delta n. Delta n you have to find out. Delta n is equal to number of moles of gaseous product minus number of moles of gaseous reactant. That you have to remember that there should be in the what? Gaseous form is there. That is, they should be all they are in what? In the gaseous form. Okay. So here what happens? Next one. Then you write down here in the number of products is there. You can see the products. Two products we are writing here. PCl3 and Cl2. There is phosphorus trichloride and chlorine molecule. So here what happens? You see here nothing will be there here. One is there. Here also one is there. Nothing will be there here means one is there here. So one, this plus one, how much it becomes? It becomes 2 here. So next one, you have to see here the phosphorus pentachloride there, PCl3. Here one nothing will be there here means one is there here. 2 minus 1. What you are getting here? You are getting as a what? 1 you are getting. That is plus 1 you are getting. Means what happens here? It is greater than 0 or less than 0 is there. So it will be greater than 0 is there. Greater than 0. Suppose if it is having greater than 0 is there, means what you will write down here? That is the greater than 0 is there means that you will write down as a Kp is greater than Kc. In the last class we have studied that 0 we are getting in the last example. This is the second example, is in the first example. So you are reading that delta n is equal to 0 you are getting, then Kp is equal to Kc is there. In this case what happens here? You are getting 1. That is 1 is greater than 0 is there. Greater than 0 is there means what happens here? Kp is greater than Kc is there in this reaction. Equilibrium constant in the partial pressure is greater than the equilibrium constant in terms of concentration. Next one, another example I will give. What is the example is there, sir? Here means there is a N2 plus 3H2. It gives what? It gives the ammonia NH3. 2NH3. Nitrogen, it reacts with the hydrogen, it gives what? Ammonia. Ammonia is also giving the hydrogen and nitrogen. So in this case, you have to find out the delta n is there here means delta n. Delta n is equal to what? Delta n is equal to. So number of moles of gaseous product, then they should be present in the form of what? They are present in the form of gaseous only. Suppose one gas is there, one liquid is there means that cannot be calculated for the delta n here. That you have to keep it in your mind. For every reaction, you cannot calculate the delta n. Only for the reaction, all the reactant and product they are present in the form of gaseous form only. Then only we can find out what? We can find out the delta n. Okay. Then delta n is equal to delta P minus Np minus number of moles of gaseous product minus number of moles of gaseous reactant. Then you will see here number of moles of gaseous product. Product is this one is NH3. How much is there here? 2 is there. Then write down 2 minus Nr, number of moles of gaseous reactant 3. This one is 1 is there. 3 plus 1. How much is it? 4. 2 minus 4. What you are getting here? We are getting minus 2. We are getting what? Minus 2. Minus 2 is there. Minus 2 is less than 0 or greater than 0? It will be less than 0. Less than 0 is there means then what happens here? Delta n is less than 0. Then what you have to write down? Kp is less than Kc. Kp is less than Kc. So like that we are finding what? That is the delta n. Understood, son? Next one you are having to one problem is there, that one. So I will solve the problems. Problem for the equilibrium for the equilibrium for the equilibrium 2NO 2NOCl in the form of gas. So it is converting into the equilibrium is at here. This is the reversible reaction is there. That is for the equilibrium diagram. So 2NO in the form of gas. So it gives plus Cl2 in the form of gas. It is also in the form of gas. Okay. So see here in this one, they are given the value of equilibrium constant. The value of equilibrium constant. Equilibrium constant Kc is 3.75 into 10 raised to minus 6 at 1069 Kelvin. At 1069 Kelvin. Calculate the Kp for the reaction. Calculate the Kp for the reaction at this temperature. At this temperature. You see here the question here. There is a for equilibrium. That is the NOCl in the form of gas is converted into NO to NO plus Cl2. This is also converted into what? Reactant here. Okay. The value for equilibrium constant Kc is, they are given the Kc value. That is what is there here? 3.75 into 10 raised to minus 6 is there. At what? 1069 Kelvin there. Calculate the Kp. Calculate the what? Kp. Calculate the Kp. Sorry, calculate the Kp for the reaction at this temperature. They are telling us that they are given the Kc value, and they are telling us that to find out what? Kp value at the same temperature. At what? This is the Kc value they are given at what? 1069 Kelvin. They are telling to us that to find out the Kp value at this temperature only. Then you have to use what? There is a formula is there, no? That we use the formula Kp, relation between solution. Kp is equal to Kc into RT raised to delta n. So you can find out here that is the delta n value. First you have to find out the delta n value. What is the delta n value is there here? You see, you have to find out the delta n value by seeing this reaction. Delta n for this reaction. What happens here? Delta n here, number of moles of gaseous product minus number of moles of gaseous reactant is there here. Then what you have to do? Then you see here. So here 2 plus 1 is there. 2 plus 1. How much it becomes? 3. Minus. That is the reactant you are turning. 3 minus 2. How much you are getting? 3 minus 2. That is you are getting what? 1 is there here. So that is the delta n value is what? Delta n value is equal to, we are getting what? Delta n value is 1 is there. Delta n value 1. Next one, you put that values here. What is the values you know? You have to find out Kp, that as it is you have to write down Kp is equal to Kc value they had given here. What is the value they had given here? 3.75 into 10 raised to minus 6 is there here. 10 raised to minus 6 into R value. So already you studied about that R value, that is the gas constant value, that is what? 0.0831 into temperature. They are only given that one is the 1069 is there, 1069. Okay. So then you multiply that one, you are getting the answer is what? Kp answer is, that is the Kp is equal to that the answer you are getting is here is the 0.0000333. So this is the Kp value. This is the what? Kp value. This is the what? Kp value. Next one we will study about what? Homogeneous and heterogeneous equilibrium. First I will write down here homogeneous equilibrium. Homogeneous equilibrium. Homogeneous equilibrium. So what is the meaning is that, sir? Homogeneous equilibrium. What is the meaning of homogeneous equilibrium is there here means in a homogeneous system the reactant and products are in the same phase. In a homogeneous system, you have to write down. In a homogeneous system, the reactant and product are in the same phase. The reactant and product are in the same phase. Same phase. Okay. You see here, in a homogeneous system, the reactant products are in the what? Same phase is there. Same phase means what, sir? Here means I will give the one example for that one example. So you can take the example is what is the example is there. Here means that last time I had N2 plus 3H2. So it will give what? It will give the 2NH3. These all reactants and product, they are present in the form of only gaseous form is there. Means the reactant and product, they are present in the same phase is there. Then this is called as a homogeneous equilibrium. What is the meaning of homogeneous equilibrium is there, sir? Here means that is in the homogeneous equilibrium, the reactant and product are in the same phase. Same phase means what here? Suppose the reactant is in the gaseous form, product should be present in the form of gaseous form. Suppose the reactant is present in the form of liquid forming, the product is also present in the form of liquid form. Suppose the reactant is present in the form of solid form is there here means the reactant and product they should be in the solid form only there here means, so we are going to say homogeneous equilibrium. Understood this one? If the reactant is in the form of solid, the product should be present in the form of solid here. Suppose the reactant is present in the form of liquid, the product is also present in the form of liquid is there means, then it is called what? Homogeneous equilibrium. That you have to understand that in a homogeneous reactant, the reactant and product are in the same phase. That means it is called what? It is called as a homogeneous equilibrium. So this is the example for what? Example for the homogeneous equilibrium. Next one we will see about the next one is very important one is the next one is the heterogeneous equilibrium. Second one, heterogeneous equilibrium. Heterogeneous equilibrium. So what is the meaning of this heterogeneous equilibrium? The same definition is vice versa we have done only. That is in a heterogeneous equilibrium, heterogeneous equilibrium, in a heterogeneous system, the reactant and the product are in the opposite phase. Are in what? We can call it what? Are in the opposite phase. That is what we term as heterogeneous equilibrium. Otherwise, different we can also write. That is, in a heterogeneous system, the reactant and product are in the different phase. It is called what? Heterogeneous equilibrium. So give the example, sir, for heterogeneous equilibrium. Here means that you can take the water that is in the form of what? Solid is there. Then the H2O in the form of what? Liquid is there. So the reactant is in the present of solid and the product is present in the form of liquid is there. So these are what? In the different phases there. So then it is called what? Heterogeneous equilibrium. Okay. Next one, we will move toward the problems on the Kp and KCl. The example is taken. Next one. Problem number first. 13.8 gram of N2O4. 13.8 gram of N2O4 was placed in a 1 liter reaction, 1 liter reaction vessel, 1 liter reaction vessel at 400 Kelvin, and allowed to attain equilibrium. Equilibrium. That is N2O4. It gives equilibrium sign is there. That is, it gives 2NO. Both are in the form of what? Gaseous form is there. It is also in the form of gaseous form. It is also in gaseous. The total pressure at equilibrium was equilibrium was found to be 9.15 bar. 1.95 bar pressure. Calculate Kc comma Kp, Kc, Kp are partial pressure at equilibrium, are partial pressure at equilibrium. Partial pressure at equilibrium. Okay, you see this one problem for 13.8 gram of N2O4 was placed in a what? Was placed in a 1 liter reaction vessel at 4000 Kelvin and allowed to attain the equilibrium. That is, the N2O4 is converted to N2O2 and 2N2O2 is converting what? N2O4. The total pressure at equilibrium was found to be 9.15 bar. And calculate, they are telling that calculate the Kp and Kc at a partial pressure at a equilibrium here. Then you have to write down the solution. How to solve this one? First you have to write down what? PV is equal to nRT. PV is equal to nRT. So here PV is equal to nRT here means, so first you have to find out what? N here. N is equal to what? N is equal to, so 13.8 gram. Number of moles, gram is there here. We have to convert into what? Moles here. How we have to convert into moles? That is given mass divided by 13.8 gram divided by that is the N2O4 molecular formula of N2O4 is what? N2O4 molecular formula is what? 92 is there here. N2O4 molecular formula is what? 92 is there. Then it gives what? It gives it 0.15 moles is there here. Then you have to put here P is equal to nRT divided by V. nRT divided by V. Then what we are getting here? nRT divided by V we are doing here means, then n value is 0.15 is there. 0.15 into R value 0.083 into temperature. Temperature already they are given here. What is the temperature is there? 400 Kelvin into 400 divided by what is the V value? V value is 1 is there here. Placed in a 1 liter. V value is what? 1 liter is there means 1 you have to take here. Volume is 1 is there. 1 liter is there. 1 you have to take. Okay. Next, what is the value you are getting when you loaded this one? There is you are getting the 4.98 bar. That much of pressure. We are calculating what? P value. P is value is what? That is P is equal to, you are getting the what is the pressure? P means what? Pressure. What is the pressure you are getting? 4.98 bars. That much pressure you are getting there. Next one, you are writing the reaction. What is this there? N2O4 in the form of gas. So it is converted to N2O4 is converted to what? 2NO2. That is, it is in the form of what? Gas is there. Next one, initial. When this reaction is going on here, N2O4 is converted to 2NO2. Okay. In the initially what happens? At initial what happens here? Initial the temperature is what? 0 is there here. Initially T is equal to 0 is there, means the temperature is 0 is there. Then what happens when the temperature is 0 is there? What is the pressure it is applying here? That we have found it, 4.98 bar. That much pressure is there. In the product side, the product is not formed here. First reactant will give the product here. Now the product will not give the reactant here. First, when the reaction begins here, the reactant is converted into product first. Means the product is still not formed here. When it is present in the 4.98 bar pressure, means we have to take what? It is not formed means the pressure will be 0. Why? Because it is not formed now still. Okay. At equilibrium. Equilibrium is at means what? N2O4 is converted to NO2. NO2 is also converted to N2O4. At equilibrium, what happens here? What is the pressure is there? 4.98 is there. So when it is converted into first, it is converted to NO2. What happens here? The pressure will be decreases first. You know, So N2O4 ಇದೇನಾಗುತ್ತದೆ 2NO2 ಅಂದ್ರೆ ಇಲ್ಲಿ ಏನಾಗ್ತದೆ. So as time passes, as the reaction goes, what happens here? The pressure will be reduces here. Pressure reduces ಅಂದ್ರೆ ಎಷ್ಟು reduce ಆಗ್ತದೆ ಸರ್ ಇಲ್ಲಿ? How much will be reduces sir? Here means the X number of will be, the pressure will be reduces here. Okay. X number ಅಷ್ಟು pressure ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ reduce ಆಗುತ್ತೆ. Next ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ? So then you see here in this side 2NO2. What happens at equilibrium? So here how many number of moles are there here? 2 number of moles in there. Here only one number. Nothing will be there here means, so you have to take as a 1 here. So 1 is there here 2 is there. Means how much the pressure will be increases here? The 2 times it will be increases. That you have to write down 0 plus 2x. 0 plus 2x. Next one 0 plus 2x is there here means the total pressure at equilibrium. The total pressure at equilibrium. The total pressure at equilibrium is equal to, the total pressure at equilibrium is equal to, what happens here? You have to add these two. Then what you are getting? 4.98 minus x plus 2x. Minus x plus 2x, what you are getting here? You are getting the answer is what? 4.98 plus x. 4.98 plus x you are getting. Okay. Next one. Next one, you see. So here what happens? Next one. So here they are asking about what? According to the questions. According when you are seeing the questions, what happened here? 4.98 plus x plus 2x plus 2x. Sorry, 4.98 plus x is equal to what? 9.15. Why it is taken as 9.15 here means, so you see here questioning the question, the total pressure at equilibrium was found to be 9.15. They are only given here in the question. What you are getting here? The total pressure of equilibrium at equilibrium. The total pressure at equilibrium will be what? 4.98 plus x is there here. But in the question they have given the total pressure at equilibrium was found to be 9.15 bar. Means that is the 4.98 plus x is equal to 9.15 here. Next one, that is we are calculating that one x value. What you are getting here? X value is 4.17 bar here. 4.17 bar. Next one, you have to find out the partial pressure of NO2 here. Partial pressure of N2O4. N2O4. I will write down here. Partial pressure of N2O4. The partial pressure of N2O4. The partial pressure of N2O4 is equal to what are the values they are given here? You see, partial pressure of N2O4 is what? 4.98 minus x is there. 4.98 minus x. Then you have to write down here 4.98 minus x is there. What is the x value there here? You can see here 4.98 minus x is there here means the x value we are finding out here. What is the x value there? 4.17 means you have to write down 4.98 minus 4.17 equal to what is the value getting? 0.81 bar. 0.81. The partial pressure of N2O4 is what? 0.81 bar is there. Next one, partial pressure for N2O4. What is the N2O4 is there here? You see here N2O4. 0 plus 2x is there. 2x here means that you have to do here means 2 you have to multiply here. That is the 2 into x you have to do. 2 into 4.17. So what is the value you are getting? 4.17 here means 8.34 bar. 8.34 bar. Okay. Next one, what you do? Next here is that is we have found out what the partial pressure of N2O4 and partial pressure of NO2, that we have found out here. Next one, you see the questions. What you are observing? That is you have to find what Kp. What is the Kp formula is there? Kp is equal to what? P of NO2 raised to the power 2 divided by P N2O4. Okay, you see this one. By seeing this reaction, you can write on the Kp value. The product divided by reactant is there here. It is the ratio of Kp value. I have written already in the expression. Kp is equal to Pa raised to A into Pc raised to C into Pd raised to D divided by Pa raised to A into Pb raised to B. That is, you have to do the product divided by reactant here. Which is the product is there here? NO2. NO2 is there. NO2. Partial pressure of NO2 is raised to the power 2. Why they are doing, sir? Here means here 2 is there. No? This 2. You have to raise to the power here. Next one, N2O4 is there. Partial pressure N2O4. Here nothing will be there here means 1 is there means. The raise to the power, we are raising to the power of the 1 here. Understood, son? How the 2 is coming here? The question is there. No? That is, you have to raise the power. Each term should be, you have to raise here. 2 is there, I raise the power 2. Suppose here 3 is there means I will raise the power 3 here. Okay. Next one, what is the value you are getting here? When you put the values, you know that one values are there here. P2 and P4. NOT is what? 8.34 whole square divided by 0.81 is there. What is the answer you are getting here? Kp is equal to what? 85.87 bar. This is the Kp value here. We have found out what Kp. In the fixed equation we have found out Kp here. Next one is what? Kc is there here. Kc how to find out here? Kp, that is the formula you know. Kp is equal to Kc into RT raised to delta n. RT raised to delta n is there here. What is the delta n value is coming here? You can find out that one delta n value. What is the delta n value is coming here? Delta n value. I will write on in this side here. Delta n here, number of moles of gaseous product. Product is what? 2 is there here. 2. Okay. Minus number of reactant here. 1 is there. 2 minus 1. You are getting what? You are getting here. Answer is what? 1 is there here. 2 minus 1. 1 you are getting. That is means the delta n is equal to what? Delta n you are getting for this reaction is what? 1 is there here. Next one. So what you have to do here is that is we have to find out what Kc is there here. Then what you have to do? Kc is equal to Kp divided by RT. Okay. Then what is the Kp value? We know no that you put here Kp value 85.87 divided by R value. R value is what? 0.083. 0.083 into temperature. The temperature already they are given 400 Kelvin is there here. Then 400. So then we are getting the answer is what? We are getting the answer is the 2.586. 2.86. That is the what? Kc. So here we are found out at what? We are found out at the Kp and Kc value here. Okay. I will once again I will explain this one. So in this problem, what they are doing to calculate you for you that is the calculate the Kc and Kp value here. They are given that 38 gram of N2O4 was placed in a 1 liter of the reaction vessel. This is the what one reaction vessel is there here. In that reaction vessel, what they are keeping here? 13.8 gram of N2O4 placed in a 1 liter reaction vessel. This is the 1 liter reaction vessel is there. In that one, they are keeping what? 13.8 gram of N2O4. Then at 400 Kelvin temperature is there. This is tube is placed in what? 400 Kelvin temperature. Then what happens here? They attain the equilibrium. When the 13.8 gram of N2O4 that is placed in a what? 1 liter of vessel at 400 Kelvin, when we are keeping that one Kelvin, then what happens here? Equilibrium is attained here. That is N2O4 is converted to 2NO2, 2NO2 is converted to N2O4 here. Okay. The total pressure at equilibrium was found to be 9.15 pressure. The pressure at equilibrium was 9.15 is there. Next one, calculate AC and KP for the partial pressure at equilibrium. Here means first you have to take the pressure, you have to find out here. For find out the pressures, 13.8 grams is there, that you have to convert into what? Moles here. Moles. How to convert the moles here means moles. N represents what? Number of moles. Number of moles is equal to what? 13.8 divided by 92. 92 is the molecular mass of N2O4 is there. That I have taken. N2O4 is 92 is there. 92. Now 38.92 you are doing here means so you are getting 0.15 here. Number of moles. N value you are getting. P is equal to nRT divided by V. I have it here. Then I multiplied this one. I am getting the pressure. I got here is the 4.98 bar pressure. So you consider in this reaction, first you have to write on the reaction. N2O4 in the form of gas converted to NO2 gas here. Okay. So total when the T is equal to 0 initial was temperature is 0 is there. Then what happens here? 4.98 bar pressure is there. That is I have got here. That I have here. And products are keep it at 0. Why you have keep it at 0 here means? So here what happens? Here the initial concentration will be 0 is there here. Means so the temperature is also what? Still the product is not formed here. NO2 is not formed. So because of that one I have taken here 0. Pressure is 0 is there here. So here next at equilibrium what happens here? The equilibrium what happens? The N2O4 is converted into NO2. The NO2 is also converted to N2O4 here. So the pressure will be reduces here. Pressure will be reduces. So because of that reason I have taken here minus x. X means that much amount of pressure will be reduces here. So 0 plus 2x I have taken. Here what happens? 2 is the number of moles is there here. 2 into x I have taken. 0 plus 2 into x means what happens here? Twice it will be the pressure will be increases in the product side. Next one. So the total pressure of the equilibrium is equal to what? 4.98 into x plus 2x. I had added these terms here. Then I am getting the answer is what? 4.98 plus x. So in the 4.98 plus x is equal to, according to the question, they are telling that 4.98 plus x is equal to what? 9.15 bar here. That I had written 9.15 bar. Okay. Then I found out the x value. That x value that is I have put in this one reaction. 4.98 partial pressure of N2O4 is equal to 4.98 minus x. X is values of 4.17 is there. I have written the answer. Next one, partial pressure of N2O4. N2O4, what is the N2O4 is there? 2x is there here. 2x means 2 I have written here, x value 4.17. Multiply that one, I have written this answer. The Kp, how to find out the Kp? Product divided by reactant. Partial pressure of product divided by reactant here. So each concentration term should be raised to the power here. So here what I added? Add the NO2 value is 8.34 is there into raised to the power 2 I have taken. 2 why you are taking sir here means here NO2 2 is there here. 2 is there means that the 2 should be raised up to the power here. Okay. So P2 and 2O4 that I have done is 0.81 here. Next one, the Kp value I have gotten is about 85.87 bars here. So to find out the Kc, I am using the relation Kp is equal to Kc into RT delta N here. The Kc is equal to what? Kc if delta N is becomes what 1 here. How? 2 minus 1. Here product 2 is there, number of moles. So sorry, number of moles. The coefficients are 2 is there here. Here 1 is there. 2 minus 1 here into the delta is equal to 1. 1 is there here means what I did here? Kc is equal to Kp by RT. I have put that values. I am getting the value is what? Kc value is 2.586 here. So this is the problem about the by using the this relation between Kp and Kc, we are finding out the value of what? Kc is